So what's up everyone, welcome back once again. So in today's video we will be talking about memory, especially memory when it comes to chatbots or chat applications. So I think if you have been building especially RAG systems, this memory is one of the components that you actually need to infuse if you're going to build a dependable chat systems. There are of course different types of memory. We have the long-term memory. So this I think when you're talking about the long-term memory, most of the time they will involve the vector database where you are storing your vector embeddings generated from either images or text data as from text data. I think those are the ones that you might store in vector databases. The reason as to why they are considered as a long-term memory is that they do change with time, but they are not as rapid as the short-term memory, which we are going to be actually covering today. So for the short-term memory, consider this as a type of memory that actually remembers the previous interactions within a single thread of conversation. Okay, so you might be having multiple types of conversations with different people. So if I'm talking to my friend Peter, then we're having a type of conversation about AI. Okay, so then when Mark comes in, does not mean that Mark might be having a different conversation with Mark that is totally different from the one that I'm having with Peter. So having a short-term memory will enable us to will enable me to actually keep that conversation that I was having with Peter within the domain or the boundaries that we have actually set out or defined maybe during the start of that conversation. Okay, so when Mark comes in, he has first to understand whatever context. For him to join our conversation, he has to first understand whatever context that we are having so that he can chip in. But if I sideline Peter because I want to just engage with Mark, there's another dimension of conversation that we are having with Mark. Okay, then having a short-term memory will enable us to actually shift that conversation so that we are not mixing up within these two. So let's dive deep into short-term memory. And for this one, I'm going to use LangChain LangGraph to actually build these short-term memories. But before we actually start building this type of memory, let's first understand the core components of this short-term memory, how we can actually build this, and what are some of the characteristics or some of the things that we need to consider while building these types of short-term memory. Okay, so just an overview. Memory is a system that actually remembers information about the previous interactions. So when you're having this conversation, and for this conversation to be actually fruitful, that means that we need to remember whatever we have been discussing, whether we have agreed or not. But I should have that memory system to actually remember that interaction to make our conversation actually fruitful. Okay, so for the AI agents, or consider these as your RAG systems or any model that you're actually building, memory is actually crucial because it lets us to actually remember the previous interactions. So that means that whenever we are engaging that conversation, any new query that I'm asking or any question that is coming from the other side, it does not seem as a new interaction. We're able to remember from the previous interactions, then just continue rolling over within that particular context. So we're able to remember the previous interactions, learn from the feedback that we're getting from that, and even adapt to the user preferences. We might reach a time we might pivot to another conversation. So our model should actually able to notice that and it proceeds accordingly. So as agents tackle more complex tasks with the numerous user interactions, this capability becomes essential for both efficiency and even a user satisfaction. Okay? So if your model actually forgets the previous conversation, it becomes very hard to actually have that conversation. Okay, so short-term memory lets your application actually remember the previous interactions within a single thread of conversation. Okay, from my previous example with Mark and Peter. Okay, so we are not able to mix I'm not able to mix the conversation that I was having with Mark with Peter. So each conversation is actually stored separately, so that even if we revisit later, we're able to continue that conversation. Okay, so conversation history is most common form of short-term memory, because it's just interaction between the other person or the model with your question. So you ask a question, the model generates a response. So there's that type of interaction. So but when you're having this conversation, so the length of the conversation can actually pose a challenge to the LLMs. So a full history may not fit inside the LLM's context window, resulting in context lost or even errors. Someone might actually argue that, these large language models have this massive context window. Why should I bother with conversation history growing larger? I think it should be a concern, because even though we have this massive context window, it does not mean that when we dump all this conversation into the LLM, it's able to note all the nuances in our conversation and use that to actually build on what we are going to be discussing downstream. Okay, so even if the model supports the full context, the LLMs will still perform poorly over the context, because they get distracted by stale or even off-topic context that they have some meaning within our general conversation, but it's not a major part of that conversation, all while suffering from slower responses time and higher cost. Because if you have to first deposit this or dump all this, a string of 100 messages into the LLM for it to actually gain or get what we are actually talking about, then giving us a response, then we might have a response time. So that means the latency will actually increase. Another thing is about cost, which is a key factor when you're actually building chat applications that use LLMs as part of the general application. Okay, you are being charged in terms of tokens. So having this dumping all that entire conversation will actually be costlier for your chat application. So chat models accept context within using messages, which include the instructions, so the system messages, and inputs, that's the human messages. So in chat applications, there's that alternation between messages, between human inputs and the model response, okay, resulting in a list of messages that actually grow over time. So, and because context windows are actually limited, I think I've largely explained about that. Many applications can actually benefit from using techniques to actually remove or forget stale information. So downstream, we'll see how the different types of embedding this into our model, so that the model can actually put a cap. So this information beyond this, we don't need it, so we can just forget that information. Okay. So in terms of usage, so to add short-term memory, so this is how you can actually build these applications. So in terms of usage, you can actually add short-term memory. To add the short-term memory, so this is the thread level persistence to an agent, you need to actually specify a checkpointer. So you can define this, but in most cases, yeah, we can define this, but sometimes you can even use databases like MongoDB for that matter. Okay. So, but in production, use a checkpointer backend by use a checkpointer backed by a database. So in our model, in the one that we are going to actually build, I will be using a MongoDB for that purpose, because we need that agent to actually store these messages, so that even if we are going to delete or forget these messages within the memory, we are not actually deleting that interaction. So the interactions will be stored in MongoDB, but we'll just be loading a portion of that conversation into memory, so that you're not forgetting whatever we were discussing in the previous interactions. Okay, so you can see for this they're using Postgres. You can use, but for my case, I was using a NoSQL database, MongoDB. I'll be using MongoDB for that. Customizing agent memory. So by default, agents use the agent sets to manage the short-term memory, specifically the conversation history via the message key. You can extend the agent state by additional fields. So custom state schemas are passed to create agent using this state schema. So when we are actually building this, you'll see how we actually utilize this element in the model that we'll be building. So what are the common patterns? So with short-term memory enabled, long conversation can exceed the LLM context window. So common solutions that we can employ so that we are saving on cost, which is an important factor, and that we are not dumping this conversation into our large language model. So there are techniques that we can use. So we can trim the messages. So this one, you'll remove the first or the last n messages before calling the LLM. So depending on the use case, you can actually use this. Then you can actually delete messages. So delete messages from LangGraph state permanently. You can also summarize. So this one is also another important element, so that whatever conversation that you're having with your model, you're able to summarize, to give a summary of that conversation. And this summary is some form of rolling window. So for each response of the query that you're asking, you're able to pick that information, summarize it, and add it onto our previous summary, so that you're able to build a general summary or a holistic summary on what we are actually discussing. Again, because we'll be trimming messages, this summary will be important because it saves a little bit of context within which that conversation is happening, and it can be important downstream. Okay, so you might, let's say you have 20 strings of messages with your model, and you're saving the last 5. So you're saving conversation 15 to 20th interaction. Okay, but maybe you want to make a reference to what you were discussing maybe in the 6th interaction. Okay, so having a summarized messages for that, you're able to actually pick on you're able to pick on what you were discussing previously, so that whenever you bring in maybe something older, your model is actually able to remember that, and then whatever response is going to curate will be according to your previous interactions. Or you can even use the custom strategies. But for my case, I think we'll be using the trim messages and also the summarized messages, and also the custom strategies. So for the custom strategy, what I tried to implement is to use, we can extract entities, the entities. I think if you have come across graph database, entities and their relationships, okay? So you're able to extract those entities and relationships, and you're able to store those as part of short-term memory, okay? So for the trim messages, most LLM have a maximum supported context window denominated in tokens. So one way to decide when to truncate messages is to count the tokens in the message. History and truncate whenever it approaches that limit. So if you're using LangChain, you can use the trim messages utility and specify the number of tokens to keep from the list, as well as the strategy. So are you keeping the latest or the oldest messages? Okay. So again, this is how you can actually implement that. Then you can also delete the messages. I think we have covered this widely. Again, another one is about the summarized messages. Okay, so the problem with actually trimming or removing the messages, as shown above, is that you may lose the information from culling of the message queues. Because of this, some applications benefit from a more sophisticated approach of summarizing the message history using a chat model. So you can summarize that message to be summary, but in a rolling window. So that even if I'm going to delete my messages, or I'm going to forget a certain portion of messages, I'm still able to maintain the entire context of having that conversation. Okay. Then access memory. You can access and modify the short-term memory state of an agent in several ways. So we have the read short-term memory in tool. So you can access the short-term memory. So this is the read short-term memory. So you can access it through the tool runtime, or you can even write the short-term memory from tools. So to modify the agent's short-term memory during execution, you can return state updates directly from the tool. So this is useful for persisting intermediate results or making information accessible to subsequent tools or prompts. I think we will be using this one in our model. So when you start on that, you'll actually see how we can integrate this. So for the prompt, access the short-term memory state in middleware to create dynamic prompts based on conversation history or custom state. Okay. So I think I also used this one, so that this is the output. What is the weather in San Francisco? So it calls the tools, then it gets the weather. Hi John Smith, the weather in San Francisco is always sunny. So this is the get weather. Then is the dynamic prompt. Then we are passing that as a tool. Then is the dynamic system. Okay. Before model, access the short-term state before the model, or you can also access it after the model itself. Okay, after the model. Okay, so I think that covers what we will be discussing, or what we will be doing. Generally, what we will be doing under the short-term memory. So we'll be coming up with a way to actually implement this. Using so I'll try to integrate the other, like the MongoDB, so that then we build a front end interface so that you're able to delete charts, you're able to access previous charts, so you're able to create new chart, you're able to delete if you want to delete that, plus other things. Okay. So that's what we will be covering in the subsequent video. So I think tomorrow we are going to start on the actual the building process itself. So this one will be just our guiding principle. So if you are watching this, maybe please take time to maybe go through this documentation, so that whenever we start the actual implementation, we're able to follow through and understand whatever we will be discussing. So I think that's it. That's it from me today. Thank you for your time. And if you're new to this channel, please consider subscribing to the channel. I will be sharing more of this because I will be sharing more of this. So until next time, see you.